Hello everyone and welcome to this video presentation on the Gauss-Seidel method. In this video, we'll explore the principles, implementation, and application of these powerful numerical techniques. So at first, we go with first these objectives and materials needed. So at the end of this activity, the students are expected to have been able to construct a function script using MATLAB, demonstrate your understanding on solving systems of linear equations, understand and implement Gauss-Seidel method to find solution to system of linear equations using software. Materials needed: MATLAB, FreeMath, Mathematica, or similar software. So we're going through the first procedure. So the pseudo can be found in Offline Numerical Methods with MATLAB for Engineers and Scientists by Stephen C. Chapra. So page 218 is shown below. So this one. So okay, we'll start for this. So let me show you my pseudocode breakdown first. So this is my pseudocode breakdown. Let me show you. So this one, so what is the function definition for this one, for this code, for this pseudocode breakdown? So function x equals to Gauss-Seidel close parenthesis a and b, es and max it. So it defines the function, and Gauss-Seidel that takes the coefficient matrix A, the right hand side vector B, the stopping criterion es, and the maximum number of iteration maxes as inputs. It returns the solution vector x. So for this input validation, if margin greater than 2 or at least 2 input arguments required, and semicolon, so checks if at least 2 input arguments close parenthesis a and b are provided. If not, it shows an error. So if margin greater than 4 is empty, close parenthesis max it equals 50 and semicolon. So for this one, if the if the number of input arguments is less than 4, or if max it is empty, it sets max it to a default value of 50. So for this one, if margin greater than 3 is empty, close parenthesis es equals to 0.0001 semicolon, and so if the number of input arguments is less than 3, or if es is empty, it sets es to a default value of 0.001. So close parenthesis 0.001%. So for this one, for next matrix size check, so m and n equals size close parenthesis a semicolon. So it gets the size of matrix A. So number of rows m and number of columns n. So for this one, if n equals n, so error matrix A must be square n. So it will check if matrix A is square. If not, it shows an error. So for this one, initialization, so C equals A. So initialization matrix C with the values of matrix A. So the loop for I, equals 1 semicolon, and initialize the diagonal elements of C. So diagonal elements of C to 0, and the solution vector is x to 0. So what is the next? So this one, decomposition and setup. So the loop for I equals 1 semicolon n. So it modifies matrix C by dividing each row by the corresponding diagonal element of A. So the loop for I again equals 1 semicolon n. It computes the vector d by dividing each element of b. So by the corresponding diagonal element of A, so what is next? So for the last one is this, so iteration. So iteration, iter equals 0 semicolon. It initializes the iteration counter. So the while parenthesis 1, close parenthesis 1, loop starts the iterative process. So XOLD equals X semicolon. So it stores the current solution vector in XOLD for error calculation. So the loop for I equals 1 semicolon and updates each element of the solution vector X using the Gauss-Seidel iteration formula. So the approximate relative error EA close parenthesis I is computed for each element of X. So RTER equals RTER plus 1 semicolon. Yeah, so it increments the iteration counter. So the condition if max close parenthesis EA greater than EA, so RTER less than max it, so break and checks if the maximum approximate relative error is less than or equal to the stopping criterion, or if the number of iteration has reached the maximum. If either condition is true, the loop is terminated. So for this pseudocode breakdown, what is the summary, or for summary for this pseudocode breakdown? So the pseudocode implements the Gauss-Seidel method for solving a system of linear equations. It initializes matrices and vectors, performs iterative calculations, and checks for convergence or maximum iterations to terminate the process. So let's proceed to the next one. So demonstrate Newton's method using MATLAB. So okay. So demonstrate new method using so first, let's create a MATLAB function that implements Newton's method to find the root of a user-defined function. So this way. Let me show you my code. I will delete this, or I will make a new script also. So this one. So for this code, the code defines a function Newton method that accepts a function handle function. So a coefficient matrix A, so a constant vector V, and a tolerance tol as inputs. Citation semicolon 3, it returns the approximate root y and the number of iterations. So if the tolerance tol is not provided, it defaults to 0.001 close parenthesis 0.01%. So what is the maximum of iterations for this? So the maximum of iterations for this is the maximum number of iterations n max is set to 100 to prevent infinite loops. If the method does not converge, citation semicolon 3. So next is what is initialization for this. So the initial guess for the root y is initialized as a 0 vector with the same size as b. Citation semicolon 3, the number of iterations is initialized to 0, citation semicolon 3. So for this new method's iteration, so this code iterates using for a loop up to n max times, citation semicolon 3 inside the loop. So The function of